All right, welcome to this video. I'll be here explaining the second exercise for my AI class, which is the flocking group behavior exercise. So let's begin. So first of all, we can have a quick overview of the general scene in Unity. So I have a scene set up with each props has colliders with proper lighting. And in hierarchy, I have them organized, and I have a flock manager set here. And as you can see here, I set up the group ghost prefab and the leader prefab separately as a public reference. And I'll be spawning one ghost, and it will be filled up in an array. And this is the fly limit box where constrain the flying area. And this goal position indicates that the center of the spawning, the flying limits will be at the position of the flock manager. And this is the setting I set for my flock manager to have the best result so far. And now we can quickly go to the let's go to the core of the thing, which is the I have to in this folder I have to prefab that I'm using. One is this ghost prefab, the other one is this ghost leader prefab. And obviously the important thing is I attach the flock script, which it has this setting, which set the obstacle layer into the obstacle layer, which I'll explain later. And now we can take a quick look at the script. So in the flock script, this is the parameters. These are the speed, minimum speed, max speed, and I also have these for the I also implement some extra features because with this it is able to avoid collision with object with colliders will change its behavior. So we'll see later. And at the start we set the initial speed, and I add this in case where it has null reference error, defining flying boundary, the turning logic, and here it's an important extra feature I did, which is avoidance. So I declared a new vector 3 called avoidance direction, which is calling this method down here. It does this. Basically, it is declaring a new, returning a new vector 3, which has a collider, which loop through which has an array of colliders of nearby objects. And for each collider call in all the nearby objects. So the waveform object. So for each collider in call in nearby objects, it will add the value to the avoidance direction and will return a normalized avoidance direction to indicate to calculate what should be the avoidance direction to the collider. And here, if the avoidance direction is not 0, then prioritize obstacle avoidance using the quaternion slip and loop rotation. And if the distance to leader is bigger than the neighbor distance, which means that they are too far from leader, so they should focus on following leader. So if anything else, then that means it's too close to a leader, then apply the flocking rule. And this is a little fun thing I added to add a little up and down motion to have a floating feeling. And now here, this is the most important part, which is the where all the flocking rules are applied, where all the flocking rules are. So obviously we have three parts: separation, cohesion, alignment. So here, this is initializing all the three elements into a zero vector three and initialize the group size to zero. And for separation, this is where it really what really matters a lot. Where this is this is to go through all the game object, and this is to calculate the distance between the game object or between the ghost in this sense. And here is how the separation goes, where for each nearby ghost within the avoidance distance, a separation vector is calculated. And the vector points away from the nearby ghost, and its magnitude is inversely proportional to the distance. So this makes the ghost steer away from other ones when they are too close. And alignment is about mainly about here, and then um, here. So for each nearby ghost within the neighbor distance, its forward direction is added to the alignment vector. And after accumulating all neighbor directions, the average is calculated by dividing by the group size. So this results in a direction that represents the average heading of nearby ghosts. And lastly about cohesion, these are the related code mostly. So about cohesion, the position of all nearby ghosts within the ghost distance are summed, and the average position is calculated by dividing by group size. The cohesion vector then points from the current ghost position to this average position, and then finally normalized to a unit's length. So with this, it is able to move towards the average position of nearby flockmates, keeping the flock together as a group. And then we can quickly look at the leader flock. So start, it sets a new target, which is a method I did. Which looks like this. It's where it randomly chooses a position within the flying range. And about the leader flock, so this is the way it goes. And I added whooping movement, which gives a more random, interesting result. And it will switch moving direction for every 1000 frames. And this one, it adds a little upside down motion to simulate a ghost floating effect. This is where I implement perform the whooping motion. Then let's go back to the flock manager. In the flock manager, these are the references to the prefabs on the ghosts. As I said, the 50. These are mostly the same as the template. This is but I added this. This is to initialize the leader and initialize all the ghosts as in array. This part is initialize the leader as well, and all the leader to the end. It puts to the end of the all ghost array. So finally, let's see how it works. So I'm not gonna touch these preferences. These are all set up, and let's see how it looks. we'll go to the game view. I already set up a nice camera view. So as you can see, we can see the ghost is flocking around this area where the object is actually altering, it's affecting its movement, where it's the group is slightly break apart when they are trying to pass through the object, and they are trying to avoid it, and then after they pass it, the the different ghosts will emerge together. And all the ghosts, besides the general rule of flocking, where they avoid the separation, cohesion, and alignment. Besides that, they are following the leader, which is I set another prefab called ghost leader prefab, and I assign it to a different material, so it we have a clear indication, visual indication who is the leader, and all the ghost position is led by the leader. They are essentially following all the leader, meanwhile maintaining in a group. That's how I'm able to get this interesting result. And yes, as you can see, it's flying around this area I set up, and each 1000 frame will change the direction, and it breaks apart trying to avoid the objects. And we can go to it and see carefully how it looks like. So yeah, that's basically everything. So thank you for watching.